Good morning. Thanks for coming. I'm Diego. I'm going to present this model process to create applications with Jenkins, Docker, and Conan for embedded and IoT. And here's my colleague Daniel that will also be presenting with me. So the fact that we are in embedded or IoT doesn't mean that we don't have to use model processes to create this code. Exactly what we want, what we're developing, exactly the same in desktop, as Dan said, is we want a controlled environment. We want to have builds that are reproducible, both in CI and also in our developers' machines. And we have to have a fast and traceable, easy to trace CI and CD process. This usually means to create and manage our binaries in a controlled way. So our talk today is basically a live demo with many pieces. We are going to use this Raspberry Pi here live with a blinking LED, the most complex application for IoT out there for demos. And we are going to use the wiring Pi library to control the input-output ports of the Raspberry Pi, and we are going to use this technology. So let me first introduce Conan. Conan is a package manager for C and C++. It is open source, MIT license, do whatever you want with it. It handles any build system. It's something very important for embedded because we usually have to deal not only with CMake, but also with Makefile projects, and also very custom, let's say, build system that sometimes providers, vendors give to us. And we have to handle that. And we also need to create the binary from sources, and sometimes we have pre-built closed source binaries that we also have to manage. And Conan can also manage them for us. It is a very live project. It has more than 2,000 stars in GitHub, an amazing community, especially in Slack, in the CPP Lang Slack. There is a Conan channel with more than 500 people, very friendly. It's a very good resource. And there are many, many hundreds of companies using Conan in production as today. Many of them using it for embedded. The Conan model to handle our binaries is, first, it is decentralized. It's the same model as Git. You can get binaries and get packages from one remote server and upload them to your own remote server and have that kind of copy there. And you can have as many remote servers as you want. Then for the binaries, we have the concept of a recipe. A recipe is the descriptor of the package itself, the way how it's built from sources. And then for every recipe, we can have any number of binaries. Each different configuration of the operating system or the compiler version, the runtime, the architecture, anything we change in this configuration will generate a different binary for us. And they can also be in the servers and they can be in the client because let's say the layout is basically the same. So now I'm going to introduce the first part using Conan with this part here. I'm going to create a package for the wiring Pi library, and I'm going to put it in a server, in a JFrog Artifactory server. By the way, it's also the C Serverless Community Edition is also free. And from there, I will pass control to my colleague Daniel, so he will be using this already built binary for me for creating his application. Okay, so I'm going to show you the package recipe first. Here it is. It is a Python script that describes how to manage, how to create this binary. The first interaction section, besides the name, the license, the metadata, is this one. The settings and the options, this is the binary model of our packages. This means, if you change the operating system, or if you change the compiler or the architecture, you will get a different binary. Or if you change it is a static or dynamic library, it will be a different binary. Okay? The compiler, it also has different subsettings, as the runtime, for example, or the standard library, the libcxx we are using, it will also affect our binaries. So this is a subsetting of the compiler setting. Then we have the functional part of the recipe. It is several methods here. The first one is the source one. The source one will typically say, hey, my sources for these packages are in this location. In this case, I'm cloning a repo from Git, and I'm checking to a given branch. Typically, the branch will be matching the version of the package that I'm creating the package. You can also snapshot sources inside the package if you want, or you can use an SCM proxy to get these sources. Then we have the build method. The build method is the place you can call any build system. If we have helpers for CMake, AutoTools, Visual Studio, but if you need to call your own build system, you just run self.run and call your build system there, and it will be building the binaries. Then we have the package method. It is extracting to extract the artifacts we want, typically the headers, the library, the license, if we are using open source. And finally, the package information method is the information for the consumers. It is telling the consumers, hey, if you are linking with this package, you have to link with a library that is called WiringPy. But you also need to link with pthread, RT, and so on. So this is for the consumers. They don't need to figure out which flags and which things they need. It will be automatically injected for them. So this is the recipe. So to create a package with this recipe, I can issue a Conan create command like this. And the first thing that will happen is that it will fail. Why? Because right now I'm in a Windows machine. Okay? My configuration here is my default configuration for my platform. Here is Windows, 64-bit architecture, Visual Studio, and so on. Okay? Obviously, I don't want this configuration for my Raspberry Pi. Okay? I can tell Conan, hey, I want to create a package for ARM architecture with Linux GCC compiler. Okay, I could provide them on the command line, these arguments. But I'm not going to do that. Instead, I'm going to use a profile file. A profile file is a file like this. It's just a set of definitions. Hey, I'm building in Windows, like this. This is the system that I'm building in, but I'm cross-building for my Raspberry Pi. And I can also define some environment variables, like the cross-compiler that I'm going to use in my Windows machine to cross-compile to the Raspberry Pi. So if I use this profile for my create command, then it will be cloning the sources as I started in the recipe. Then it will be calling CMake. Here you can see that it's actually using the GCC cross-compiler. And when CMake decides to finish, there is going to build a WiringPy library, and finally creating the package. That means this process was local in my computer. Okay? That means if I search my local cache, the package that I have in my computer, that means that I have this package. If I search for this package, if I expect this package, Conan search, you'll see that I have this binary that I created for this configuration with my profile cross-building for my Raspberry Pi. This process I can repeat for as many configurations as I want. For example, let's say I want to have debug packages. So I can repeat the process with Conan create, the same profile, but in this case I'm starting, hey, my build type is going to be debug. So this will repeat the process. It doesn't need to clone the sources again because the sources are already cached also. So it will just call CMake again to create a new build, in this case for creating debug packages. It will be building, WiringPy, and finally packaging again. That means that if I do a Conan search, it tells me that in my local cache now I have these two binaries. One binary for my Raspberry Pi, debug mode, and the other binary for release mode. Okay. These packages were created locally to my machine. Now I want to provide my colleague with these binaries for this library for his application. So I'm going to upload them to my server. So I can do a Conan upload. I'm going to upload everything to my remote that is called Artifactory local, and I'm going to upload all the binaries that I created. Yes, I am sure. It will start uploading things. And if I go to my Artifactory instance here, I refresh, I will see that here I have the two different binaries. the one release for the Raspberry Pi, and the one debug for the Raspberry Pi. So now the packages, they are available. Okay, if I build this for different compiler versions, different architectures, all the binaries will be also listed here. Okay, so now it is ready. Everything is working fine, but this has a trick. Okay, I had to previously install the cross compiler in my Windows machine, so I was able to build this package here. Okay, now I'm giving the word to my colleague.
Okay, can you hear me? Yeah. Okay, so thank you, Diego, for the first part of the talk. We were saying that what we have, the trick was that we had everything set up in our machine, everything locally, the cross compiler. We have even make to compile for the make file of the library. So I think we can go a little bit further, and we can have that controlled environment. And here is what we are proposing. Using Docker, and even go a little bit further even and use Jenkins for our continuous integration. So what I'm proposing is using a Docker file like this. This will build an image that will set up everything. As you can see, you have there the compiler, you have the archiver, you have the linker and everything set up. And you have like your environment, everything controlled, everything in the same place, so you can reproduce your build and you can get started building this setup very quickly. So for the rest of the setup, here what we are going to use is going to be Jenkins for continuous integration. We are going to use it in the multi-branch approach. This is very convenient because you may have like different configuration if you are building in a branch for develop or if you are building for a release. And things that will also be fine to use. For example, in the Jenkinsfile, we are going to use the Artifactory plugin, which is very convenient to use with Conan because it's going to make very easy to communicate with the remote. You don't have to set up any authentication. But you have like a really nice DSL programming language to compose your Jenkins pipeline. We are going to build inside the Docker image with the control environment I told you. And as you will see, we will follow the same Conan steps that we did manually, but we are going to let Jenkins handle everything. So this is the part that we are going to demo now. We are going to build our Blink application. Well, we are going to let Jenkins do it. So we are going to make a change in our Blink app that is already running in the Raspberry Pi. Then we will let Jenkins look for our changes and call Conan and, of course, get the WiringP package from the Artifactory remote, build our application, and then upload it again to our Artifactory remote so the Raspberry Pi can update itself. So this is the Jenkins file we are going to use. As you can see, I think it's very descriptive. At the top, we have some variables defining our local remote and also the Docker image that we are going to use. As you can see, it has the same name that I showed you before. And here it is creating the server. It is also creating a new instance of the Conan client. And it is handled under the hood all the authentication and configuration of the remote and so on. One thing that is interesting, at the top you can see in the Docker image that we are mapping some directories. This is to keep the log of Jenkins to not lose that data if we want to know what the job did in the past or we want to go back and check what it was doing. We are not going to lose the log, because the Docker image will stop. So we need to to keep that file. And we are also, if you notice, at the top, we are mapping the network. We are mapping the network of the Docker container, and we are mapping it to the machine where Jenkins is running. This is because we want to communicate with Artifactory, so we need to use the same network. And as you can see, it has 3 steps. We are getting the project with our new changes. And now it's getting the dependencies in the Conan create command. That create command will also retrieve the dependency of WiringPy library, and it will just compile it. And the last step, it will get our Blink application and upload it to the server. So let me go through this and show you this is actually what we are going to do. So I have here my project. This is, as I told you, the Jenkinsfile that is in the same repository. And here is our application. Nothing very complex. It is just using the WiringPy library. It is just setting up the WiringPy, setting the mode to the pin mode for the GPIO 0 to output. And this is just putting the GPIO to high and low and with a little delay. So the difference in the Conan file, in the recipe that we use at Conan, it's mostly the same as the one that Diego showed you. But the most important thing is that we have a requirements part. We have a requirement on the WiringPy, and we are making it conditional. This is because maybe you want to support different architectures, and maybe you don't need that library. You don't need to link with that library. So you can make it conditional to your architecture or whatever you want. If you want to build different flavors of your application, you can handle it in the Conan recipe. And this is just going through the build step. It's injecting this definition for the WiringPy, and the rest is self-descriptive, I think. So let me go to the main application and make a little change. So Jenkins can pick the change and build the new application for us. So I'm here in the repository, and if I check the changes, you see that I have just changed the delay time. So let me commit the changes and let Jenkins do the stuff for me. So as I am running everything locally for the demo, I don't want to rely on the network. So Jenkins is set up in this same machine, and it will check out the local repository. As I don't have like a hook or anything like you may configure if you are using GitHub or if you are using a Git server, it is scanning with a little delay. It is scanning the repo, the local Git repo for new changes. So we will have to wait a little bit until the job starts. But the main part that I want you to make aware is that this is only going to build our application. It is not going to build the library. The library is already built in the server. We don't have to waste time building everything again and again. So we can let Conan handle that part, handle the requirement, bring it from the server, and let Jenkins just build the application in our control environment. So if we have luck and Jenkins is not lazy today, maybe we'll get it running. It's taking too long. No, because the repo is local, so Jenkins is maybe the refresh. that made the trick. Thank you. So as you can see, you can see here the three stages, just getting the project, the create step, that is actually getting the dependency of the wiring pi library, and then the last step that will upload it. So in the last step, if our application gets uploaded, the Raspberry Pi will get updated with the new version of the Blinking. So here you have the change. Now it's blinking a little bit faster. So we make through the whole process, and now I want to show you the Jenkins log to show you that I'm not cheating. It is actually doing stuff here. But the most important part here is that it is using the Conan create step, as we did manually. And it is using the profile that we have set up in our Docker image for cross-building. So we have here the control environment. And it is actually saying that wiring pi is not found in the cache, and it is actually downloading from the server. So as you can see here, it is marked as wiring pi downloaded. So this achieves the goal that you don't have to rebuild and rebuild again your libraries, and that you have everything in control in your Artifactory repository. You have all your different packages controlled there, and even the application is here, so you can check everything. This is more or less what we have seen, the whole process of making a continuous integration for an embedded device. And I would like to finish with some conclusions. This is obviously a demo example. This is always something that you will not put into production, because it will require like more staging, like testing, QA, or maybe you want to do the final deploy manually. But I think this example will make you the idea, will transmit the idea that we are pursuing. So I think nowadays there are no excuses for not implementing a DevOps flow. I think even for embedded devices we can achieve that. We can have our testing stages, and we can have our tools gathered in one place. So what this is stating is that managing binary artifacts is important. It's important even for the embedded things. We have to handle the libraries, the dependencies. We have to handle our final application, or even for a customer. And there are many existing tools that can be applied for this. We have to use Jenkins, Docker, Conan, but maybe you will use something different for a continuous integration, or maybe you would like to handle your environment on a different way. But this is a way that we can use modern tools for our embedded systems too. So that's all from us. Thank you so much for coming to the talk. And if you have questions for me or for Diego, we will be happy to answer them.
Questions?
Great talk. I think there's a lot of future for Conan in embedded. However, the Pi is part of the embedded market. Not everything is so Pi-like. Can you speak to tool availability or support for bare metal systems or very large systems, or especially sort of the testing side when unit tests actually mean touching bits on something that's not in a server rack?
Well, I will try to answer. We know that the embedded system is a complex world. It's not everything as easy as a Raspberry Pi. But what we are proposing here is like with Conan, you get the model to target different kind of devices. You can control your binary and handle that compatible binary interface. You can handle that for different architectures and for different compilers. So it will just be a matter of configuring the Conan package system for your embedded devices. And obviously for the testing part, maybe you would like to decouple it from the embedded system and run maybe your unit test for the pure C++ classes. You would like to run it on decouple from the embedded device. And then maybe, I'm not sure, but maybe you could do like testing in the hardware with hardware in the loop and everything like that. We are not experts on that part, but I think there are steps that we can take to get to there.
Okay, thanks.
Thank you.
Hi, thanks. How does Conan play with like embedded Linux distributions? Like if you are using Yocto, Open Embedded, Buildroot, can you benefit from using Conan?
Yes, here where we are using is like I would say like a wide definition of the settings we are using. What we call settings is like the model of the package definition. I mean, so if you want to target different distributions, you can even tweak that in Conan. You can change your setting, your model, and you can generate packages with different types that will be different for different Linux distributions. So you can handle that too.
So at the end of the day, I would like to have an image, a complete file system with all the packages in it. Can Conan also do that, or?
You mean it's more for the deploy part?
Yes.
Yeah, I think as you have seen with the application, we are actually deploying things for the app, and it will also bring the dependencies. But the use of Conan is more heavily focused on the part of developing and creating packages. So the deploy part, it could help, and there are people using it also for deployment. But maybe you would like to have a different tooling for that part that gathers everything and make a package in the format you want, maybe a dev package or something like that you would like, and Conan could help with that, but it's not the main target. Anyone more?
No more questions? Okay.
Okay, so thank you so much. Thank you.